Section 2.4, guys, we're talking about complex numbers. Complex numbers are written in the standard form of A plus BI, okay? Which part is the real part and which part is the imaginary part of our complex number?
The B.
The B is what?
Imaginary.
The imaginary. How'd you know, just by looking at that the B was the imaginary part? It's got the I, right? When we talk about this I, if you take the square root of -1, it's not a real solution. It's imaginary. So write that down. The square root of -1 is imaginary. I think the way that they wrote this problem out is a little interesting to look at. So let's just work this problem out. I am going to suggest that you guys do this until you kind of really get the hang of it. But -9, would you guys agree, is the same as 9 times -1, right?
Yeah.
Okay. What is the square root of 9?
3.
3. What is the square root of -1? I. And then I have -5. Can I combine 3i and a -5?
No.
No, because one part is imaginary, one part's real. So this is your answer here. And to write it in standard form, the real part of the number has to come first. So we would rewrite this as -5 plus 3i. That's considered standard form. Questions? You guys remember this? All right. So the real part of our complex number goes first. The imaginary part goes second. The imaginary part has the I with it. Comprende? All right. So let's look here. We're performing operations with real and complex, or real and imaginary numbers that make complex. If you're adding and subtracting, guys, this is the exact same thing as just combining like terms if you had variables. Real stays with real. So if you notice, first look in between the parentheses. What's going on in between the parentheses?
Adding.
You're adding. So you just add +3 and a +2 gives me 5. So real stays with real. And then imaginary stays with imaginary. So -1, I, plus 3i.
2i.
So plus 2i. And that's it. Are we written in standard form?
Yes.
Yep. We're written in standard form. Real part comes first. Second part comes second. The I part comes second. Do what?
Can you do C?
Yeah, I'm going to do C. Can I do B first?
Are you doing all of them?
Yeah, I'm going to do them all. All right, look at the second one. How is this one a little different? There's a subtraction. So what should we do with that subtraction sign? We should distribute it. Good. So distribute it here and here. I'm going to rewrite this, and it's going to say 1 plus 2i, then -4 minus 2i. You guys agree? Okay. Real stays with real. So 1 minus 4.
-3.
-3. And then positive 2i, -2i.
They cancel out.
They cancel out. You can leave it as -3. If you were going to write it in real standard form, you could say plus or minus 0 i's. You don't have to, though. That's fine with me. Questions? Okay. All right, look at this next one. Looks like we have a lot going on. What number is right here in front of this first parenthesis that I don't see?
1.
There's a 1 there, right? So what should I do with this negative? Let's distribute it first. So I have 3 minus a negative becomes +2. Minus 3i, right? Does any sign change in the second parenthesis?
No.
No, because it's got a plus sign in the middle. So real stays with real. I have a 3, a +2, and a -5.
0.
They all cancel out, right? 3 plus 2 is 5. 5 minus 5 is 0.
Yes.
So then I have -3i and a +2i. -2i. What would I put in front of that?
0.
You could put a 0 right there and say it's 0 minus 2i. That's the complex form.
So you couldn't just do it as negative?
You could leave it as -2i. That's fine. All right, what should I do here in D? Before I start combining, let's distribute this negative. So this becomes 3 plus 2i plus 4 minus I minus 7 minus I. Whoops. Minus I. Real stays with?
Real.
So 3 plus 4 minus 7.
0.
Everything cancels. What's 2 plus minus 1 minus 1? That cancels out. So you could write this as 0. How else could I write it?
Plus 0i?
Yeah, 0 plus 0i. But you don't have to. If your real part or your complex part cancels out, it's fine. Just leave it whatever's left. That's fine. But I'm just showing you, you might see it written that way. Questions?
Like, is it, when we get like,
Does anybody what we have to remember about this?
Parentheses first.
Yep. What does I squared equal?
1.
What kind of 1? -1. Write that down. That's going to be really important because in your answers, you'll have real parts and you'll have an imaginary, but you should never have an I squared left in your answer. So let's go through this. What does this mean with this 5 stuck on the outside? Just distribute. So 5 times -2, -10. 5 times 3i,
15.
plus 15i. Can I combine anything else there?
No.
No. So it's just -10 plus 15i. What do you notice about b? Are we adding or subtracting here?
Multiply.
We're multiplying.
Foil.
Yeah, we're going to foil. 2 times 2 is, 2 times 4 is 8. 2 times positive 3i.
6i.
Yep. -i times 4. -4i. And -i times 3i. -3i squared. Now, as soon as you see I squared, I'm going to tell you guys, cross off the I squared and change the sign in front of that number. Do you now see how we just have real parts
Yes.
and imaginary? No I squareds left. I'll show you why in a second. So real stays with real. What is 8 plus 3?
11.
11. And then 6i minus 4i is
2i.
plus 2i. Now, let's look at that for a second. We had -i times 3i gave me 3i squared, correct?
So you converted it into negative.
Well, because this was a negative, right? -3i squared, and we multiplied it. So this is the same as -3. What did I tell you the value of I squared is?
-1.
What is -3 times a -1?
3. Positive.
Positive 3, which is what we have right here. Every time you have an I squared, just multiply them together, like however, I squared, you see it, you cross it off, you change the sign in front. Because what you're in a sense doing is just multiplying that number by -1. So if it's a positive, you would change it to a negative sign. If it's a negative, you change it to a positive. Good. What do you guys notice about letter C?
They're opposites.
Yeah, they're opposites. You see how the terms are the same, but the signs are different, right? Watch what happens when we have this. 3 times 3 is 9. 3 times -2i.
-6i.
Good. 2i times 3
6i.
plus 6i. And what's 2i times -2i?
4.
Yep, you're right. No, -4i squared. As soon as you see that I squared, do what?
Make it a plus.
Cross it off. Change the sign. Now combine, guys. Real with real. What is 9 plus 4? 13. What happens with a -6i and a positive 6i? It cancels out. 3 plus 2i and 3 minus 2i are what's called complex conjugates of each other. And we have to use complex conjugates in a second when we divide. But when they say to multiply by the complex conjugate, all they mean to do is change the sign in the middle. As long as your number is written in standard form, meaning the real parts first, then the imaginary part, you just change the sign in the middle. We'll talk about that more in just a second. So what do I have here with D? Okay, 4i times -1 is -4i. And then 4i times 5i plus 20i squared. What happens with I squared?
You cancel it out.
Cross it off, and this becomes what?
-20.
Can I leave my answer like that? Why? Why can I not?
you have to put it in standard form.
Got to put it in standard form. Good. So it's -20 minus 4i. The real part always has to go first. What does E say?
In parentheses,
3 plus 2i squared. What does that mean? Do I take that 2 and just distribute it here and here?
Yes.
No.
No.
What does that mean?
Foil.
We're going to foil it. This is saying, hey, I have 2 of these parentheses. I'm going to write it down. 3 plus 2i times 3 plus 2i. Are the i's going to cancel out here?
No.
Why not? I agree. Why not?
One's not negative.
Because they're not opposites of each other. Good. So 3 times 3 is 9. 3 times 2i
6i.
plus 6i. 2i times 3.
Plus 6i.
Good. 2i times 2i
4i squared.
plus 4i squared. As soon as you see that I squared,
Cross it out.
cross it off, make it a negative. Real with real, guys. 9 minus 4.
5,
6i and 6i.
12.
12i. Do you see how the i's did not cancel out? That's a big thing to notice. When they're complex conjugates of each other, like in C, the imaginary part cancels. If you just multiply by the same thing, it's not going to cancel.
I got a question.
What's up? Okay, we've already talked about this, guys. I told you when you multiply complex conjugates of each other, look, a plus bi, a minus bi. Same terms, you just change the sign in the middle. You notice that your i's will cancel out. So when we go through here, and they tell you to multiply by the complex conjugate, all right, what is the complex conjugate of 1 plus I? What's the complex conjugate? Same terms, sign in the middle changes. Okay, so what is it?
1 minus I.
There you go, 1 minus I. Now if I'm multiplying them together, 1 times 1 is
1.
1. 1 times I is negative I?
Negative I.
Yep. What's I times 1?
Plus I.
What's I times negative I?
I squared.
Minus I squared. As soon as I see I squared, I cross it off,
And make it
and I change the sign. And I make it a what, Sean?
a 1.
A 1. Good. If there's nothing there, guys, it's the 1, because I squared equals negative 1. Then look what happens with our i's. So what am I left with?
So it's 2.
It equals 2. So if I have 4 minus 3i,
4 plus 3.
and they tell me to multiply by the complex conjugate, 4 plus 3i. Again, quickly, guys. 4 times 4 is 16.
You guys gonna be able to test?
Yep, 4 times 3i.
4 times 3i is
12i. Negative 3i and 4.
negative.
Negative 12i. Negative 3i, negative 3i. I mean, negative 3i, positive 3i.
Not negative 9i squared.
When I see I squared, I do what?
You cross it out and then make it a positive.
Real stays with
Real.
16 plus 9 is 25. And what happens with positive 12i, negative 12i?
Cancel out.
They cancel. All right? You guys see that? You understand that? Well, now, the reason why we do that, okay? We've added complex numbers. We've subtracted them. We have multiplied them. Now we're going to do what?
Divide.
We're dividing. This is a super hard thing, so really pay attention, okay? If I had 2 over the square root of 3, am I allowed to leave the square root of 3 in a denominator?
No.
No. You'd have to rationalize, right? We multiply by the top and bottom square root of 3. All right. So if I am not allowed to have an I in the denominator, is there a way I could what is it?
Multiply by itself.
If I multiply the bottom, not by itself, but by what?
Complex.
The complex conjugate. What would it be? 4 plus 2i. Because what will happen when I FOIL this together? What happens?
Cancel out
The i's cancel out. Guys, what you do to the bottom of a denominator, or of a fraction, you do where? To the top. We have to be fair. That's the only thing you have to remember, guys. Now this just becomes 2 multiplication problems. 1 on top, 1 on the bottom. 2 foiling. If you do not divide, if you multiply, look, if I multiplied here by 5 minus 2i, would the i's cancel out? No, they would just double up. So you have to remember, when you are dividing, you cannot have i's in the denominator. The only way we can get rid of them is if we multiply by the complex conjugate. So let's FOIL the top. What is 6 times 4?
24.
24. What is 6 times 2i?
Plus 12i.
What is 3i times 4?
Plus 12i.
And what is 3i times 2i?
6i squared.
6i squared. As soon as I see that I squared, what do?
You
Cross it off, change the sign. So real stays with
real.
24 minus 6 is
18.
18. And then I have 12i plus 12i is
24I.
24i. Perfect. Now we're going to do the same thing on the bottom. I'm going to FOIL. 4 times 4 is
16.
4 times 2i.
8i.
Okay. Negative 2i times 4.
Negative 8i.
Negative 2i and a positive 2i.
Negative 4i squared.
I see I squared. I do what?
Cancel that out.
Cross it off. Change the sign in front. Real stays with real. So 16 plus 4 is 20. And what happens with my 8 i's? They cancel out. Do I have anything with an I in the denominator?
No.
No. Am I completely done?
Yeah. Yes.
Why do I hear no? How can you simplify it? What goes into all of them?
2.
Okay? If you can simplify, guys, you have to. 2 goes into 18, 9 times. 2 goes into 24, 12 times. And 2 goes into 20.
10 times.
So this is really 9 plus 12i over 10. We're always, always, always going to simplify. All right, guys. This right here is very important for you to understand. This slide isn't going to make much sense, but in a second when we do some problems here. What you need to understand and remember is when there is a negative underneath the square root, it denotes I. It's an imaginary solution, right? We have that in our brains. Okay, so let's do the next one. If you have a problem like this, generally, ladies and gents, a negative divided by, or times a negative is a positive. This does not become a positive number. It doesn't become positive 36. Rewrite these. When you see something like this, rewrite this as the square root of 3 times the square root of negative 1, right? Okay. Rewrite this one as the square root of 12 times the square root of negative 1. You guys agree?
Yes.
Okay. Three times 12 is what?
36.
36. What is the square root of negative 1?
I.
It's an I. What is the square root of negative 1? It's an I. What is I times I?
I squared.
I squared. What does I squared equal?
Negative 1.
Negative 1. So this is really the square root of negative 36. If I asked you what the answer was to this, what would you tell me?
Square root of 36.
What is the square root of 36?
Negative.
No. It's 6 what? I. This is the square root of 36 times negative 1. The square root of 36 is 6. The square root of negative 1 is I. The real number rule of a negative times a negative equals a positive does not translate into this because these aren't negative numbers. These are imaginary numbers. It's not negative 3 times negative 12. It's imaginary square root of 3 times the imaginary square root of 12 gives you the imaginary square root of 36. Does that make sense? Because we're not talking about real numbers here. Look at this one. What can I break 48 into? A perfect square and a non-perfect square.
4.
Bigger. 16 times 3 times negative 1, right? Because this is imaginary, correct?
Yes.
Minus, what can I break 27 into?
9 and 3.
9 times 3 times negative 1. What is the square root of 16? 4. What is the square root of negative 1? I, right? And then the square root of 3 stays here. Minus, what is the square root of 9? 3. What is the square root of negative 1? I. And then what stays underneath? Can I combine these two now? Yes, because A, they both have the same radical, quote-unquote, last name. And they're both what kind of numbers?
Imaginary.
They're both imaginary. They both have i's. So what's 4i root 3 minus 3i root 3?
I root 3.
I root 3. Perfect. Good job, guys. Very good. Last example, and then we're going to do one quadratic formula, and we're done.
Wait, how did you get a root 3?
Always put the I in front of the square root, because if you leave it like this, Is it really easy for me to tell that you understand that the I is no longer underneath the square root? Understand me? So put it out in front. Move this bad boy out here so I know for sure you know it's outside of the square root. So let's look at this one. What kind of a number is 17?
Prime.
It is prime, but is it real or imaginary?
Real.
It's real. So I have 17. You're right. 17 minus. Let's talk about 54. What can I break 54 into?
9 and 6.
9 times 6 times, what else is really important that I remember? -1. So I have 17 minus, what is the square root of 9? 3. Good. What is the square root of -1? I. So I have 3i, and then the square root of 6 stays there, right?
Yes.
Can I combine those two?
No.
Why not?
Because there is no more real numbers.
One part's real, one part's imaginary. Is this written in standard form?
Yes.
So we're good to go right there. Okay, so now if we're going to talk about a quadratic equation that has complex solutions, that means you're going to have imaginaries. What is the difference you guys see between A and B?
There's no X.
And B's a coefficient.
Okay, there's a coefficient. Good, there's a coefficient in B. What else do you notice?
And there's a 2X.
There's a 2x. There's a B term. Do you notice how there's an x squared and a constant in letter A?
Yes.
And then there's an x squared and then an x and then a constant in letter B.
Yes.
All right, so initially the first thing we would do is factor. So somebody first period said, oh, it's the perfect squares. X plus 2, x plus 2. Is that true?
No.
No. Difference of perfect squares works out to be the x plus 2, x minus 2. When it's a plus sign in the middle, it's different. If you have x squared plus 4 equals 0, and I asked you guys to solve this, what would you do?
Subtract.
Okay, subtract 4 from both sides. Let's move the 4 over. X squared equals -4. How do you get x by itself?
You square.
You take the square root. If I physically put the square root sign on top of a number, what goes in front of my answer?
X equals.
Plus or minus. X equals plus or minus. Guys, this is the same thing as 4 times -1. What is the square root of 4?
2.
2. What is the square root of -1? I. There is a major difference between plus minus 2 and plus minus 2i. If you have a question like this and you just leave it as plus or minus 2, I'm not giving you any credit. I know everybody in here can solve a simple two-step equation, but you don't understand, or you're not paying enough attention to the fact that it's a negative underneath the square root. It changes it from a real answer to an imaginary one. So don't come up to me, but I just forgot. Don't forget. That's your reminder right there, okay? All right, last thing we're going to do. 3x squared minus 2x plus 5. The first thing I would suggest that you guys do, obviously on this quiz and on your test, it's going to have a complex solution. You're going to have an imaginary. But the first thing, if I was just given a problem like this and said, solve it, I would move everything to one side. It has to be everything on one side set equal to 0. But I would try and factor. What is a times c? 15. Are there factors of positive 15 that'll multiply to give me positive 15, but add to give me a -2?
No.
No. Some of you will say, oh, 5 and 3. I agree. 5 minus 3 is, or -5 plus 3 is -2. But if I multiply those two together, I get a -15. So you have to use the quadratic formula. -b plus or minus the square root. b squared minus 4ac all over 2a. Don't even say to me, we have to memorize that. Yes. You guys can sit in here and sing a gajillion songs from every album that just came out. You can memorize the quadratic formula. Put it to music. Put it to music. All right, here we go. Last one. What is my A term, guys? What's A?
3.
A equals 3. B equals -2. And C equals?
5.
Perfect. So let's just go through. The hardest part of the quadratic formula is plugging everything in correctly. I understand that -2 is +2. If I were you, I would just write the negative, just so you don't make any silly mistakes. So we have -2 plus or minus negative 2 squared minus 4 times 3 times 5 all over 2 times 3, correct?
Yes.
Did I write everything correctly?
Yes.
All right, let's just simplify then. A negative 2 gives me positive 2 plus minus. What is negative 2 squared? 4. What is negative 4 times 3
Negative 12.
times 5?
Negative 60.
Negative 60, good. All over 2 times 3 is 6. We need to know our rules there. So let's simplify a tad bit more. What is 4 minus 60?
56. Negative 6.
Negative 56, great. All over 6. Let's break down 56. We always are going to have to break down. What times what is going to give me 56?
4 times
Ooh, good.
14.
4 times 14 times...
Negative 1.
Good, that negative 1. And then I have over 6. I'll show you guys another way you could have looked at this. No big deal. You can still get the same answer. So now let's just kind of simplify a little bit. What is the square root of 4?
2.
2. It's going to come outside. Do we know the nice pretty square root of 14?
No.
No.
So it's
Do I know the square root of negative 1?
I.
Yep. So my problem becomes 2 plus or minus 2i root 14 over 6. Am I done?
No.
Why not? You can
You
simplify, right?
Like
2 goes into 2 one time. 2 goes into 6 how many times?
3 times.
3. And then on the other side, it has to go into both, guys. 2 goes into 2 one time. And 2 goes into 6 3 times. So it's like this. You can leave your answer here. If you want to write out 1 plus root 14 over 3 and 1 minus root 14 over 3, that's fine. That 1 has to stay there. Somebody asked me first period, do you have to have that 1? Yes, absolutely, because it's saying 1/3 plus or minus I root 14 over 3. Now, real quick, when we had negative 56, all right, the easiest combination that people see is what?
8 and 7.
8 and 7. It's the first thing you were thinking, right? All right, that's fine. 8 times 7 times negative 1. Are either one of those numbers perfect squares?
No.
No. But is there a perfect square inside of 8?
Yes.
Yeah.
4 and 2.
Look, 4 times 2 times 7 times negative 1. You can still do this. It just takes an extra second. This happens a lot with 32. Because, people don't think of 16. It happens a lot with 48 as well. But if I break this down like we just did, what is the square root of 4?
2.
2. Do we know the square root of 2?
No.
No. Do we know the square root of 7?
No.
Do we know the square root of negative 1?
I.
It's I. So we take out what we can, and then what do we do with 2 and 7?
Multiply.
You just multiply it. So I got the same answer there. You will still, it's okay. As long as you break it down correctly, it's okay if you don't get the biggest and small and biggest perfect square and smallest non. It's not that big of a deal. You can write it either way. If you guys want to separate it and write it like this, perfectly fine. Just make sure you simplify. Let's just say we had this, like 3 plus or minus 2i root 5 over 9. Can this be simplified?
Yeah.
Yes. It can be. Can I simplify both terms, though?
No.
No. So you would have to rewrite this, guys. You'd have to separate it, just like Camila just said. 3 over 9 plus or minus 2 root 5 over 9. I suggest you guys always separate it. Just see if they break down. If they don't, write it back together. But what does 3 over 9 simplify to?
1.
This is 1/3 plus or minus 2 root 5 over 9. Just saying. Now, if you had like root 5 over 5, do those two cancel out? No. The square root of 5 is not the same as positive 5.